Bismillahirrahmanirrahim. Assalamu alaikum. Dear viewers, I am Dr. Noshin Afshan and you are watching Dr. Noshin Afshan YouTube. I hope that all of you would be fine and I am thankful to you for watching this video. To watch more videos, please subscribe my channel and press bell icon. So our today's lecture is about molecular orbital diagram for homonuclear diatomic molecules. For example, hydrogen, lithium, nitrogen, oxygen and fluorine molecules. And we will also discuss here that why there is no bond formation for such molecules like helium, beryllium and neon molecules with the help of their bond order calculation. So let's start. First of all, let me make it clear to you that why these type of molecules are called as homonuclear diatomic. As the homonuclear term indicates that the two atoms are identical. Owing to this reason, owing to their similarity with each other, they are called as homonuclear, and as they consist of two atoms, so these are called as diatomic. So for these two reasons, these are called as homonuclear diatomic molecules, and we will discuss here their molecular orbital representation, how these can be explained with the help of molecular orbital theory. So first of all, we discuss the case of hydrogen molecule. First of all, we write down its electronic configuration as its atomic number is 1, that is 1s1. So that means only one electron resides in 1s orbital. Here it is H1, that means its atomic number, and that is 1s1. So here we draw, first of all we write down, this is the atomic orbital of hydrogen, that is 1s, and there is one electron over here. Similarly, here is also atomic orbital because it is only one orbital, so that is okay. Atomic orbital of hydrogen over here, and this is also just 1s. Now they would overlap to generate a bonding molecular orbital, or simply you may also write down, there are two ways of representation. Simply in this form, here there would be two electrons, because in molecular orbitals they may have the two electrons at their maximum. So they cannot have more than two electrons. They may be either empty with 0 electron, or partially filled with 1 electron only, or completely filled with 2 electrons. They cannot go beyond this 2 electron limit. So in the case of this bonding molecular orbital, it would be occupied by these 2 electrons, and then in the case of antibonding molecular orbital, it would be empty. This is antibonding molecular orbital. And here this shows their energy level. On the basis of this diagram, we can calculate its bond order, or in other words, the bond order for hydrogen molecule. The definition for bond order is 1/2 of the difference between number of electrons in bonding molecular orbital and number of electrons in antibonding molecular orbital. So from this representation, as the number of electrons in bonding molecular orbital is 2 minus number of electrons in antibonding molecular orbital, this is 0 electron, divided by 2. So here 2 over 2 is equal to 1. So the value of bond order for hydrogen molecule is 1. That means this value, the value of bond order, would determine the number of bonds between two atoms. So as it is 1, so it indicates that there is only one bond between hydrogen molecule in this way. So the hydrogen molecule is formed when two hydrogen atoms form a single bond. So all this is the molecular orbital diagram for hydrogen molecule. We will discuss the molecular orbital representation for lithium molecule, that is Li2, that stands for lithium molecule. As you know that the atomic number of lithium is 3 and its electronic configuration is 1s2 and 2s1. So for 1s, here these are the atomic orbitals of lithium. Here it is also atomic orbitals of lithium. We will start from 1s orbital. Here, as you know that there are 2 electrons in 1s orbital, so these 2 have been placed here and here. When they would overlap with each other to form a bonding molecular orbital, 2 electrons would be here, and in the case of antibonding molecular orbital, 2 electrons would go there, because here there are 2 and 2, 4 electrons, and then 2 would be in the bonding molecular orbital, and the other 2 among these 4 electrons, 2 would be here, and the remaining 2 electrons would be in antibonding molecular orbital, and the energy level increases from bottom to top. And then there comes the 2s orbital. Here it is 1s and 1s. This one is 2s orbital. Here there is only 1 electron in this one, and also here is also 1 electron only in 2s orbital of the other lithium atom. So they would overlap to form bonding molecular orbital, and here there would be 2 electrons, and in the antibonding molecular orbital there would be no electron at all, because these are only 2 electrons which would be occupied by the bonding molecular orbital. So owing to that reason, the antibonding would be empty. Now move towards its bond order. So just calculate now the number of electrons in bonding molecular orbitals. Then here there are 2 electrons and also 2 electrons. You have to calculate the number of electrons in all the bonding molecular orbitals. So here there are total 4 electrons, and in antibonding there are 2 electrons here and no one is here, so only 2, and divided by 2. So here 2 over 2 would be 1. So here again the value of the bond order is 1, which determines that there is only one bond between 2 lithium atoms to form lithium molecule. So actually molecular orbital representation paves the way towards determination of the nature of the bond, either its covalent or ionic bond, and also whether there is the probability to form a bond or not, means the probability of bond formation. The molecular orbital theory gives us the information about 2 factors: the nature of the bond, whether it's covalent or ionic in nature, and the number of bonds between atoms. So now our next example is Our next example is helium molecule formation. The question about helium molecule may arise. So our next example is formation of helium molecule, whether the helium molecule exists or not. We have to prove it via molecular orbital representation. The question that may arise like, why attractive forces between helium atoms may not exist? Justify the statement. So in that case, let's take the example of the helium molecule. The atomic number of helium is 2 and its electronic configuration is there are 2 electrons in 1s orbital. So its energy level increases from bottom to top. Okay, as there are 2 ways of representation, whether you draw an orbital like this, or in other case you just put a line to show the 1s or any other orbital like 2p or furthermore orbitals. So in this case we just draw a short line over here to show the 1s orbital. Here it is 1s orbital, it is also 1s orbital, as there are 2 electrons. So these are here. This is of 1 helium atom and this 1s orbital is of 2nd helium atom. So this would be overlapped to form. Okay, if we use a line system over here, then we also write down a line over here to form or to show the bonding molecular orbital. And also in the case of antibonding molecular orbital, we will also use a small line. So here there are total 4 number of electrons, and these 4 number of electrons would be distributed like 2 in bonding molecular orbital and the remaining 2 in antibonding molecular orbital. And then their bond order would be, here the number of electrons in bonding molecular orbital are 2 minus in antibonding molecular orbital this is also 2 divided by 2. So this is 0 over 2, it's also 0. So this value of the bond order determines that there are no attractive forces exist between helium atoms. There are no attractive forces, that means there is no bond formation between helium atoms. So owing to that reason, the helium molecule cannot exist. So thank you very much for watching the video. Please subscribe my channel and press bell icon. Allah Hafiz.